I recommend that anything that I write on the board, you also write down. If I feel like it's important enough to put up here, it's something that you should be looking at again. Also, I will always give you at least one, but oftentimes many examples of all of the kinds of homework problems that I will give to you. And so it's really important for you to always give yourself that advantage by, if you're going to take notes on anything, at least the examples, because that's what you'll need later on when you're doing your homework. I am going to give you homework today, if I can find where I put it. I think there it is. But hopefully it should be something that is easy enough that you can complete here within our class time. Okay, so before we do anything else, let's learn a little bit about what chemistry is. Chemistry, unfortunately, is not just the explosion of things, even though that's maybe what we want it to be. It's also not just, like the Breaking Bad side of chemistry. It's not just like the manufacture of medications, legal or otherwise. So here's your definition of what chemistry is. It is the study of matter So to review, you should have learned this back in some day. Does anybody know what matter is? It's anything that has mass. So some things that are matter, your paper, your notebook, hopefully the waters that all of you are drinking. Good, stay hydrated. It's going to be a really hot day. What else is matter? The gas that you're breathing, the air that you're breathing, all of that is matter. The things that are not matter, thoughts, feelings, not dealt with in chemistry. So chemistry is the study of matter. Its properties, so how hard is it? Does it float? Does it burn? Does it react with other substances? Those are all properties. It is also the study of the changes that matter undergoes so when something evaporates, or when something boils, when something is crushed, when something explodes, the changes it undergoes. And the last thing, the energy associated with those changes. Chemistry is the study of matter, its properties, the changes it undergoes, and the energy associated with those changes. So when we're talking about properties, that's where we'll learn about how substances are, like kind of their being, their essence. The changes, we will learn how substances react. And the energy we will talk about towards the end of the school year. Do you need to add energy in order to make a reaction progress, or does it give off energy on its own? Neither of them is good or bad. It just means that you need to know what your situation is. Okay, so this is what chemistry is. And as you can see, it's really a pretty broad definition. And so as long as you are thinking about physical substances, even the ones that you cannot see, you're thinking about chemistry. So that's why we really refer to chemistry as the central science, because all the other sciences depend on matter. And if we are already investigating all of these things about matter, it means that all of the other sciences are being discovered through chemistry. That's why, humbly speaking, it's the best of the sciences, because all of the other sciences are just different branches, really, of chemistry. All right, so we're going to spend some time talking about the properties and the changes today. So first we'll talk about the properties. There are two types of properties for all substances. There are the physical properties. And I'm just going to draw a line in the middle. And then there are the chemical properties. And the way that we distinguish between these two types of properties really tells us what we are going to be investigating as we go through the course of, I guess, any foray into chemistry. Physical properties are things that you can observe just by looking at the compound. But also by, like, if you, as long as you're not changing the compound at all. So I'm just going to write under here, can be observed without changing the nature. I'll explain that when I talk about chemical properties of the substance. This is kind of a hard thing to understand sometimes, because you can find out physical properties by making changes to substances. And so hopefully I'll try to do a good job of explaining this and how you can figure out the difference. Okay, so examples of physical properties, like the easiest ones would be color. My lab bench is black. Physical property. Some other properties, what something smells like is a physical property, because you can observe it without doing anything to the substance. So Jake left his water bottle in my classroom over the summer with a liquid IV in it. So when I opened it up this morning, because this idiot doesn't come to school with a water bottle, even though he's got to play a football game tonight, doot-de-doo, when I opened it up, it had a smell. That's a physical property. And then I put boiling water in it with my special soap, and the cap is like all bent, so it didn't go on properly. So then I spilled boiling soapy water like all over myself. He's not favorite child today. Smell is a physical property. Another physical property would be hardness. So you can take a piece of chalk and smash it with a hammer and determine how hard it is. In the same way that you could take a hammer to this faucet and see if it makes a dent. You're not changing the nature of this substance, you're only changing its shape. So that would be a physical property. So that would mean shape also is a physical property. And then the main physical property that we talk about in chemistry is the state of matter. Do you know, there are 3 states of matter, do you know what they are? That's it. So the fact that Jake had liquid in his water bottle, like that it wasn't, I don't think there was any mold in it. I don't think there were any solids. But the fact that it was liquid is a physical property. Density also is a physical property. Do you know what density is? Anybody? It's okay if you don't. You find it by taking the mass divided by the volume. So density is really like how many atoms are packed into a space. So for example, you can have two, pretend that they're identical pieces of paper towel. Here's the first one. Here's the second one. Which one has the higher density? This one, right? Because there's more matter shoved into a smaller space. Higher density, lower density. That's what density is. It's a physical property because it can be observed without doing anything to the substance. I can unfold this piece of paper towel if I want to, and it doesn't change the essence of a paper towel. It still is a paper towel. All right, so then the chemical properties are not that. You can only observe chemical properties, can only be observed by attempting a chemical reaction. Chemical properties are only observed by attempting a chemical reaction. I'm using that word attempting deliberately, so make sure you copy that down in your notes. All right, so I'm going to explain this by giving you some examples. The first chemical property that comes to my mind is flammability. Now, we'll discover this throughout the course of this school year, and definitely next if you decide to join me in AP Chemistry. Chemists have like their own little lovely language, and we like to have different words that mean the same thing as other English words that we already use, but we feel like it's fancier if we use these other words. So flammability just means, will it burn? So burnability, I guess you could use as the same word for flammability, but if something is flammable, that means that it will burn. Not everything is flammable. For example, asbestos. Have you guys heard of asbestos? It is a fiber that was manufactured, gee whiz, like maybe 100 years ago, and it was used as a flame retardant because it doesn't burn at all. And so in the olden days, when you had a curtain on stage, those curtains were made of asbestos because the lights before electricity that lit up a concert hall or a theater would be candles because we didn't have electricity or gas lamps. And so the curtain, because it hangs down so far, had to be made of a flame retardant material, something that was not flammable. And so asbestos was used because it doesn't burn at all. Unfortunately, the fiber, if it gets airborne and into your lungs, causes really serious disease. Have you heard on TV the commercials about mesothelioma? That's the disease that asbestos gives you. It's terrible. So flammability. Here's another chemistry word, corrosiveness. If something is corrosive, it means it reacts with acid. I have two ongoing experiments over here on my lab bench. This is a sample of nickel metal that was dissolved in hydrochloric acid, and here same thing in nitric acid. Not all metals dissolve or react with acid, but if something is corrosive, that's what it means. So this was a penny, and I put it in acid. And isn't it beautiful? So, what? Because all of the water evaporated. And so now it just has formed these crystals, but it's so humid that actually there's some water trapped underneath here. That's the dark region, is there's just water trapped under here because it's so humid. And this one became juicy again. It was all crystallized over the winter because it's very dry in here over the winter, but it's so humid now that it's reabsorbed all that moisture. Let's see. What would be another chemical property? reactivity, I think, is the best way to describe it. So when something does not react, so remember in the definition I said it can only be observed by attempting a chemical reaction. You only know if something burns or not by lighting it on fire. You only know if something dissolves in acid or not by reacting it with the acid. But the lack of those two things is also a chemical property. So for example, have any of you guys had a sports injury where they had to put a metal in your body? Do you know what metal they used? Usually they use titanium. Titanium is an element of the periodic table. It is element number 22. The reason that titanium is used as a joint replacement metal is because it doesn't react with bodily fluids and it's incredibly light and strong. So it has physical properties. It's light, its density is low, it's strong, it has a high hardness, but also it doesn't react. So chemical and physical properties are used to come up with titanium as the metal that's used in joints. So chances are, Donovan, you just got the titanium. So the fact that something does not react is a chemical property. Now, there are some different things that you can do to tell if something is, let me think about that. That's moving on. Anybody need me to keep this up for a minute? Can I move on? Okay, that's to remind myself for later. Okay, so those are the physical and chemical properties. Let's talk about the changes. There are also physical and chemical changes that we have to distinguish between. So a physical change is anything where you're not changing the essence of the matter. The main physical changes are changes of state. So those changes would be when you have, you're going from solid to liquid or liquid to gas, in either direction. So freezing would be liquid to solid, melting is solid to liquid. Evaporating is liquid to gas, condensation is gas to liquid. I maybe should write these down. Melting equals solid to liquid. Freezing is the opposite, liquid to solid. Condensation, if you don't have an insulated water bottle, right now you're experiencing condensation. That's when you're going from gas to liquid. Evaporation is the opposite of that. That would be liquid to gas. There is one other term that you probably have never heard before. I ran out of space here, so please continue this list with this word. Sublimation describes in either direction going from solid directly to gas without going through the liquid phase. You have probably all experienced sublimation before. If you've ever seen dry ice, you see it, there's like the nuggets, or sometimes there'll be a brick of dry ice. Dry ice is solid carbon dioxide. It's just at a really low temperature. And when you see it like making that like foamy gas kind of, like it looks like it's smoking, what you're seeing is sublimation. You're seeing it go from a solid to a gas without it becoming a liquid. So there is a question on your homework about sublimation. If you hear that word, think physical change. Some other physical changes, I'm just going to go on to a new slide. Is it okay if I change it? Okay. I ran out of space. I wasn't smart about it, what I was doing there. You guys good back there? What was I gonna say? Oh, other physical changes. Anything that you're doing that could be, you're just changing the shape of, really, is a physical change. So when my mom gets in the car, most of the time I don't want to say most of the time, but just a lot of the time, she hits stuff. And so that like denting of the car, that would be a physical change. So any changes of shape. So when I crumpled up that piece of paper towel, that was a physical change. If you smash something, that's a physical change. If you cut something, that's a physical change. When you go to get your hair cut, last year when Court had his little barber shop, physical changes. When I yelled at Mr. Dermis, probably chemical changes. So when you're deciding between the two, if the substance in question hasn't changed itself into some other form, it's most likely a physical change. So now I'm going to go back up to this other slide so I can fill in some of the chemical changes. Now, the chemical changes are a little bit easier. There are 4 main signs. There are others, but these are the main ones of a chemical reaction. I'm just going to do it now because I'm going to do this throughout the entire school year. The abbreviation that I use for the word reaction is RXN. So if you ever see RXN, think in your mind, Miss Bishop means reaction, she's too lazy to write it. Okay, so there are 4 main signs of a chemical reaction. The first one is a change in color. So remember though that color is a physical property. But if something changes its color, that shows that you've had a chemical change. So for example, when I go to the salon and get my hair colored, that is a chemical change. So here's another one. Remember that smell was a physical property? If there's a change in smell, that indicates a chemical reaction. So do you guys cook at home? You do something, you make something, you make Easy Mac? Do you make macaroni and cheese? Do you make popcorn? Okay, I'm trying to think of something that you could like all relate to. What's something that you do make? Toast. Okay, that's perfect. Okay, so what does it smell like when you have a perfectly golden piece of toast? It smells good, right? What does it smell like when you burn your toast? It's not good, right? It's a bad day. So that change of smell indicates that there's a chemical reaction. So what's happened? You basically burnt your bread. Like even the light toasting, you're just basically burning it. You're just not going as far as like the burning part. You guys roast marshmallows? Chemical change, because you can smell it right in the air when the marshmallow starts to cook, because you like what you're smelling is the caramelizing of the sugars, or like the breaking down of the sugars. So change in smell indicates chemical change. If you are producing a sound or light, this is a good indicator that you have a chemical change. You guys have used glow sticks? Yes? Yeah. Okay, so how do you make a glow stick glow? You crack it. So what you're actually doing when you crack a glow stick, there's a little tiny glass tube, it's called a capillary, and when you snap it, it's releasing chemical inside of it. And so that chemical reacts with the chemical on the outside of the tube, and that reaction produces light. That's called phosphorescence. what was I gonna say? So that's an indication of a chemical reaction because you've produced light. Sound is a little bit more, you have to be careful with sound because if you've ever played with slime, when you like squish it, it'll like make the fart noises, right?
Yeah.
That's not a chemical change. That's not a chemical change. But if you are hearing somebody toot in class, that sound would be the indication of a chemical reaction. Who was it that was in here that was just absolutely dropping ass without impunity? Charlie. Charlie was in here the other day for Jet Block. Joe was they were working on something. And they were actually working, but he was just letting it rip. You know who also lets it rip? Father Doug. Have you ever, you gentlemen, have you ever served with Father Doug? Has he ever been the priest while you've served at Mass? Well, just caution, because it happens. It happens. It happened to Joe last week. And then the last one is, production of a gas. I almost forgot. So if you have a reaction that you can see gas being produced, it could be a chemical change. But again, this one is a little bit hard because gas you can see produced when you are boiling water, and that's only a physical change. So you have to be careful with production of sound and production of gas because those two are a little bit, it's not always true. But again, if you're tooting, you're making the sound and producing the gas, that's a chemical reaction. Okay, so some examples then of chemical reactions would be when something lights on fire. Let me do this way. The fact that iron rusts is a chemical property. If you guys drive a car, that's something that you have to worry about. You don't want the rust. You don't want the body of your car to get rusty because then it doesn't look good and it's bad for your car. But the fact that gold does not rust is also a chemical property. Because remember that if something doesn't react with something else, if something is inactive, that's a chemical property. So this is an indication that there's no chemical reaction. That means that it's a chemical reaction though. Because what you're saying is that this reaction does not happen, but the only way to have proven that this reaction does not happen is to attempt the reaction. So I know that's kind of circular logic, and I apologize, but brace yourself because there's more where that came from. All right, so what I want to do, what do you think? So are you the guilty party today? Yes, that's what happens. Donovan, let's just put it this way. If you don't finish it in class, you're doing something wrong. All right, so the whole first page of this homework you can do, but let's just do a couple of them together. So number one, a plum ripens. That makes me want to put on here anything in the aging process is a chemical reaction. So anything that's aging, a banana getting black, Chemical reactions. Well, you can because you can smell that that's a thing that happens, and you're watching it change color. So, chemical reaction. So, number one, a plum ripens. Is that chemical or physical?
Chemical.
Dominic, did you have a question?
Yeah. So people.
People, you are constantly, unless you're dead, which also is a chemical reaction, your cells are constantly going through chemical reactions. I think that, I might be wrong on this, but I think that this is true. Every 7 years, all of your cells have regenerated so much that, like, who you were 7 years ago is not, there are no cells that are left that are who you were 7 years ago. I think that's true, but that's biology and that's not my science. So constantly right now you're having chemical reactions. Did any of you have a snack for, raise your hand if you had a snack for snack. I had a snack for snack. So if you ate anything today, that's all a chemical reaction. If you're drinking anything other than water, that's a chemical reaction because your body has to metabolize all of those things. So if you had a bubbler, or if you are enjoying a bubbler right now, your body's metabolizing the caffeine in there. So anything in the aging process. What about number 4? An inflated balloon gets larger when heated. Chemical or physical? Hunter says physical. Is he right? He is. It is, but remember that any time that you are changing the state, even because like you're just changing the temperature of things. That's a physical change. Well done, Hunter, you were right. A silver tray tarnishes. What number is that? That's number 5. Look at number 5, please. Tarnish is the word for rust when we talk about silver. Patina is the word for rust when we talk about copper. Like, you know how copper, like if you used to have a copper roof, it's green now because it like rusted, but that, we don't use the word rust for that. So would number 5 be chemical or physical? Chemical? Correct, because it's the same thing as iron rusting. Okay, what about sad days, number 6? A cake burns. Chemical. Yep. Smelly. Okay, what about number 7? Iron melts at 1535 degrees Celsius. Why do you say that? Correct. We wrote that word down in the blue side, so that is a physical change. Alcohol is very flammable. Is my sink clean? Do you want to see how flammable alcohol is? Let me go get some. Hang on. All right, if I can find some matches, I'll show you where, how, hey, watch your language. Yeah, it's the kind of alcohol you drink, but so little of it, Jared, will put you into a coma, because it's like pure.
That's like what it's like the stuff.
It's almost, it's 95.
So it's like everything. So it's kind of like the stuff they use to like knock people out.
Well, that would be ether. Yeah, an ether or chloroform. I don't have chloroform. All right. I think you guys probably want to come up here for this. I need a little beaker. Okay, so I just need a volunteer to I'm gonna flip my. I need a volunteer to hold the tablet so that Hayden and John can see this. Anybody want to be the tablet, the cameraman? David wants to. All you have to do is point this at the sink. All right, so what I'm going to do is I'm going to put some alcohol. I'm going to put some alcohol in the sink. Now my sink is made of slate, and so it is not flammable. So I'm going to put some alcohol in here. That's probably not very good coverage. I'm going to put a little bit more. I also got some on my fingers, so I'm gonna have to wipe that off before I light my match. Otherwise, that's not gonna be a good look. And then I'm gonna light a match and drop it in here. Oh, sad days. I let it go out in the air.
Yo, can you move the flame over here?
Sure.
Thank you. Appreciate it.
Oh, I gotta have some for later.
Holy
So it's pretty flammable. Now the nice thing about this is that once it stops, once it like burns itself out, it'll just be done. So do you see like the dry parts of the sink already?
Yeah.
It's just burning itself out. It's a pretty nice little fuel if you want to have a nice little flame. It doesn't last very long though.
looks a little hot.
It is a little bit hot.
Would it burn you?
I mean, put your hand over the sink. Don't put your hand in the sink, but I mean, it's hot, yeah. It's hot. If you like have little metal ends on your bracelet, those will get hot and then they might.
I did that with a fork when I was little. I'd hold it over the flame and then touch it and then get hurt.
That's seems like a hunter thing to do.
I didn't learn. I did it like 3 times until I learned to stop.
That seems like a hunter thing to do.
And my mom would bandage my finger and everything.
Wow, look at you. Thank you, David. I appreciate you.
Stop.
All right, you guys can take a 4-minute brain break.
Why would you pour it down the entire tray? But it doesn't match down with the whole pipe. Like,
It just no, because there's probably enough